Welcome to our session on object-oriented programming with Java. My name is Deepali Pal. I am going to walk you through the basics of object-oriented programming and particularly how we do that in Java. Java is a mature and widely used programming language, so learning Java will be very important for your career. In this class, we will highlight the basic building block of Java classes and how this can be used to implement object oriented design. In an object oriented framework, we consider everything as an object, such as a building, bank account, student, and so on. We are going to cover the detail of Java classes and main four pillars of object oriented programming, that is encapsulation, inheritance, abstraction, and polymorphism. Let's go into further details. Also, please feel free to ask me any question. You can comment or question under comment section of this video. Let's take a look at the conceptual picture of an object. What do you see there? You can see there are data attributes and the methods that interacts with the attributes. So we can conclude that an object can store the data and it can perform operations on the data. When we write a program in Java, the data is represented by attributes or variables and operations are implemented using functions or methods. That immediately gives us a reflection question. Now, from procedural Java programming, we know that we can use some primitive data types such as integer, double, etc. to store data. Now the question is, how are the objects different from those? You can immediately see that the primitive data types can only store data and there are no operation associated with them. On the contrary, an object can store data and it can perform operation on data. In the code snippet, you can see a simple string object and you can also note it can perform a number of functions on the data that it stores. Here we have used ends with function. You can see there are other Java string methods also. So we understood what is an object. Now we want to know how we can create an object. Let's try to understand by an example. Now we are all familiar with the buildings. So when building is built, an architect typically makes a plan or blueprint first. Then the builder builds the building out of that blueprint. The same blueprint can be used to build a lot of building. In a program, the objects are comparable with the building and the classes are comparable with the blueprint. So the classes contain the attributes and function specification and object can be considered as an instance of a class. We can create multiple instances of a class, each representing an independent object. Now, as I mentioned earlier, please feel free to ask any question or comment in the comment section of this video. Now it is a time for a little bit of coding. To the left of this slide, you can see a Java class called rectangle. So we use the keyword public class, then the class name rectangle to declare the class. You can immediately see the attributes length and width in line number 4 and 5. Then we define a special method constructor in line number 7 to 11. We will discuss in detail about the constructor later, but for now we can say that a constructor is used to create a new instance of a class. Just like we showed in the code snippet to the right, where we created a rect object using this class rectangle. Note the new keyword as well, which says a new object is being created. You can also see two arguments, length and width, are passed to the constructor. In this way, we initialize the object rect. You can also see a set of mutator and accessor functions. In Java, we generally use get functions such as getWidth, getLength as accessor, whereas the set functions such as setLength, setWidth as mutators. These are the conventions we follow when we code in Java. Now let's talk more about the constructor. A constructor is a special method which is automatically called when an object is instantiated from the class. It has the same name as the class. There can be two types of constructors: default constructor and parameterized constructor. The parameterized constructor contains arguments to initialize the object, but default constructor does not use any argument. The specialty of Java programming language is that when you create an object, the constructor is always called. If we don't write any constructor in a class, then Java automatically provides a default constructor at compile time. Now time for a question. What is the purpose of a constructor? To be very precise, there are two purposes. Number one, object instantiation, and number two, object initialization. As an object-oriented programming language, Java facilitates function or constructor overloading that gives us more flexibility to code. As an example in the code snippet, you can see two functions with same name add. They have different return types and their arguments have different data types. The first one accepts two integers while the second one accepts two strings. So I would like to remind you that if you have any question or comment, please feel free to write that in the comment section of video. In the next 4 slides, I will be going through 4 pillars of object-oriented design. The first one is encapsulation. Now the encapsulation combines data members and methods of a class. In the code snippet, you can see a person class with a data member called age and two methods, getAge and setAge, to retrieve and set the age. The main purposes of encapsulation is data security. This is handled by a mechanism called data hiding to avoid access to the data members methods. This is to ensure that the data integrity is not violated externally. Now, The data security is accomplished in two steps. In the first step, we specify the access modifier such as public, private, protected, or default to the data members. In the second step, we provide public get and set functions to access or modify the data. Now next, we discuss about another key property of object oriented programming, which is called inheritance. Now inheritance is a process of object oriented programming by which characteristics are inherited from ancestors. In Java, we create a new class which is derived from an existing class or a base class. So inheritance ensures that we can successfully do code reuse. Now as an example, we can define a base class animal which has one function, it. Now animal class can be extended into another class called dog. When you do that, the dog class inherit it function from animal class. It can also contain other methods like bark. So here animal is a parent class and dog is a child class. It represents an is a relationship between parent and child. There is another interesting property of object oriented programming design which is called abstraction. Now data abstraction is a process of hiding certain details and showing only essential information to the user. We can achieve abstraction in Java using abstract classes and interfaces. Now from the code snippet, you can clearly see that to access the abstract class, it must be inherited from another class with an extends keyword. On the other hand, to access the interface, we must implement it by another class with implements keyword. In the next session, we will have more discussions on abstract classes and interfaces. Finally, we can now talk about the fourth feature of object oriented programming, which is called polymorphism. In general, polymorphism means many forms. It occurs when we have many classes that are related to each other by inheritance. In the code snippet, you can see a parent class called animal, and this is extended by two classes, pig and dog, where we implemented the method animal sound differently. There are two flavors of polymorphism, method overloading and method overriding. Method overloading occurs during compile time, whereas overriding occurs during the runtime. In this class, we introduce you to the objects in object-oriented framework. We discussed about Java classes and how they can be used to create objects. We also discussed basic building blocks of object-oriented programming using Java code snippets. We'll learn more examples and hands-on coding in our next sessions. Let me know what are questions or comments you have for me.